Okay, this is Math 2, and we're going to do 80 through 83 in this video. Okay, and then the first one says, use the diagram of circle C at the right, or in this case, I copied it down to the bottom to answer the following question. Each part is a separate problem. So for the first one, it says if x is 28 degrees, what is the measure of arc AD? So this actually shouldn't be that big of a deal. So if x is 28, let's say, so this part over here is 28 degrees. How much is AD, which is this arc over here? Well, first thing to recognize is this is half of a circle, so this whole thing from A all the way down to B is going to be your semicircle, or 180 degrees. And then if this is 28, then this part over here, which takes care of well, actually, this is your intercepted arc, and this is your, inscribed angle, and then this is your intercepted arc. So this is going to be double 28, so this is going to be 56 degrees. And then if the whole thing is 108, then figure out how much AD is. So then the measure of arc AD is equal to what? Okay, I'm sure you can figure that out. Okay, and then the second part says if AD, the side length, is 5 and BD is 5√3, what's the area of the whole circle? Okay, so let me erase this. So that was part A. Okay, and then part B, if AD, so this line right here, so from A to D is 5, and then B to D is 5√3. Then the question is, which is this part right here. Now, the important thing to remember is this is still 180 degrees. So that means this part is 180 degrees. And since this angle here, which is ADB, subtends this arc, then this angle here has to be 90 degrees. So you have a proper right triangle. And then you need to find the hypotenuse. And the easiest way to do that would be, okay, 5 squared plus 5 square root of 3 squared is equal to, I don't know, we'll call it D for diameter, right? This whole thing is your diameter. Diameter squared. So 25 plus 5 square root of 3 squared is 25 times 3, 75 is your diameter squared. So this is 100 is your diameter squared. So your diameter is really 10. Right, so this whole thing is going to be 10. Okay, and then that leaves your radius 5, because it's half of your diameter. So what's the area of the whole circle? And the area formula for the circle, you need to look that up and figure out what the area of that circle is. Okay, all right, so that was part B. Part C is a little different. So pause if you need to get this down, because I'm about to erase it. Part C says if the radius of circle C is 8, okay, this ought to be interesting. What are we looking for? The segment BD. Okay. Oh boy. Okay. Oh, so this is trig. So if the radius is 8, okay, so this means this is 8. So the whole diameter is going to be 16. All right, that's nice. This is still 90 because that's still half a circle. And then we have, if BD is 100 degrees, so B to D, so out here is 100 degrees. Okay, so this must be 80 degrees. Yep, okay. So that's 80. And then what are we looking for? BD. Okay, if that's 80 degrees, this arc out here is 80 degrees. That means this angle here is going to be 40 degrees. Alright, so we're looking for BD, so I guess we could call it W, right? Just call it W. Oh, we have to use trig for this. Okay, so that means we have a triangle. There's B, this is D, this is A. This is 40 degrees because it's half of 80. That's your arc. That's your inscribed angle. 16 is the hypotenuse, and you want to find W. Okay, well, set it up. you're going to either, well, I'm going to tell you right now, you're not going to use tangent. So you have to decide, with the 40 degrees being where it is, are you going to use sine or are you going to use cosine? Okay, so then W is equal to what? Okay, that was 80. 81. Assume that B is the center of the circle. Match each item on the left with the best description for the right column. Okay. You should be able to handle this. This is just vocab matching. The only thing I would make sure is you understand that the arcs, right, versus the segment. So AD is the arc, AC is the arc, AB is a segment, CD is a segment. So it's something to do with angles and arcs. That's usually in degrees. So you should be able to handle 81. All right, 82 is a little weirder, but that's okay. Let's see. Jamie was supposed to have completed a portfolio, and she started her geometric construction and never really finished it. What's the name of the triangle center that Jamie was constructing, or constructed, technically X, and what special properties does it have? So this is what we were starting to do, or this was the question, I think it was 91, where you had to plot the points and it was a town and then you had to make a circle around it. So she was actually constructing the perpendicular bisectors of every single part of this triangle. So the question is, which one is it? Is it a centroid? Is it a circumcenter? Or is it an incenter? So this was, to finish this off, right? There's another line that's supposed to come out from here. It's supposed to be at 90 degrees, and it's supposed to be, is it a perpendicular bisectors? They should be constructing perpendicular bisectors. It could just be perpendicular. No, that doesn't make any sense, because you'd have to know where. Okay, so these are all perpendicular bisectors. Presumably all these parts are equal, I think. Well, we'll see. Anyway, so it hits at that point X in the middle. Now, here's what she was trying to do. So once you have that point, and I'm going to use the compass really quickly. Once you have that point, and you put this down, and you're supposed to, technically, if I'm doing this correctly, you're supposed to figure out, if you draw a circle, I don't think this is going to come out because I don't think this drawing is to scale, but we'll see. You're supposed to be able to create a circle where it actually touches all the corners of this triangle. And my circle kind of moved, so, but it is relatively okay. So technically, this circle, right, you can connect all the three corners of the triangle after creating the perpendicular bisectors. So this is actually called, if I'm not mistaken, it's called the circumcenter of triangle TRA. So you have the circumcenter that is created from perpendicular bisectors of a triangle. Okay, so they are perpendicular and they cut the segments in half. Okay, compute the volume of the figure at the right. So the book, actually not the book, the internet was actually pretty good about breaking this apart, so I thought I'd click on the hint, and sure enough, this is technically like a step. If you really think about it, here's the first step, the second step. The volume of it, we want the length times width times the height of each part of this. So the internet was actually pretty good about breaking it apart into two equal pieces. So just to be sure or clear, if you actually break this apart, 6 is the whole height, and 6 is the whole height here. The entire length of the base is 10 centimeters, but since this is 4, this is going to end up being 4 also. This is 3, that's 3. So if this is 4, has to be 4, so the remainder of this is 6, so it can make up the whole thing. And the whole length times width times height. This whole thing is 5 also, because everything, all the steps are the same. 5, 5, 5, 5, 5. So break it apart. So this is the 6 part, that's 5, that's 6. This is 5, the whole length of it, that's 3, that's 4. So technically 6 times 6 times 5, and then 5 times 3 times 4. Find the volume of this part, multiply those together, pretty much add them up, and then find the volume of the whole thing. And we're done with 83. So that was it. Just breaking apart the picture would be a good idea. Try to draw it. It actually does help you because it's going to help you later on. Trying to draw these three-dimensional shapes out. Actually, if it helps, I always like doing the insides. Right? It's supposed to look something like that. If you really want to do the three-dimensional shape. Okay, that was 83. 84. Is this where I'm stopping? Oh no, I think I'm done. Okay, next videos, it'll be the other ones.